to propel this new era of American energy dominance. First, we will begin to revive and expand our nuclear energy sector, which produces clean, renewable, and emissions-free energy.
President Donald Trump observes nuclear power is both a renewable resource and an emissions-free source of energy.
A complete review of U.S. nuclear energy policy will help us find new ways to revitalize this crucial energy resource. And I know you're very excited about that, Rick.
Back in the 60s, Alvin Weinberg saw the molten salt reactor as a means of addressing energy pollution and the need for clean water. Power centers would co-locate energy-intensive manufacturing and small modular reactors. Surplus power would be sold to nearby communities. He knew energy was the ultimate raw material. The more energy you have, the easier it is to recycle and use virgin materials more efficiently. Given enough power, we can pull carbon right out of the atmosphere or ocean. China announced their plans to develop and commercialize a thorium-fueled molten salt reactor in 2011.
And your deposit has 8% rare earths. It may have 14% thorium.
One rare earth and usually one thorium atom.
There's so much rare earths that we're throwing away because of thorium.
Rare earth materials used to make high-tech products like advanced batteries that power everything from hybrid cars to cell phones. We want our companies building those products right here in America. But to do that, American manufacturers need to have access to rare earth materials, which China supplies.
So I have a friend who's trying to start a rare earth mine in Missouri, and all he wants the government to do is to just let him put the thorium aside for future use. So I asked him, Jim, how much thorium do you think you'll be pulling up a year? He goes, I think about 5,000 tons. Is that a lot?
There was 60 people sitting on the other side of the podium going, do you think there's a stable supply?
5,000 tons of thorium would supply the planet with all of its energy for a year. So your one mine would bring up enough thorium without even trying to power the entire planet. There's like a zillion other places on Earth that are just like my mine. It's a nice mine, but it's not unique. It's not like this is the one place on Earth where this is found.
We could use thorium about 200 times more efficiently than we're using uranium now. This reduces the waste generated over uranium by factors of hundreds and by factors of millions over fossil fuels.
The molten salt breeder was one thing that he had a feeling in his heart for.
Molten salt is one of the best decisions I made, I think. High temperature is easier than high pressure.
He didn't like the fact that it had to run at really high pressure.
In some very remote situation, conceive of the containment being breached.
The molten salt reactor experiment was one of the most important, and I must say, brilliant achievements of the Oak Ridge National Laboratory.
You nuclear engineers are probably going to think those are fuel rods. They're not. They're graphite. The fuel was a liquid that flowed through channels in this graphite. Instead of having solid fuel and a liquid moderator, liquid fuel and a solid moderator.
One of the hardest things to get around is the large, heavy pressure vessel that's required when you use pressurized water reactors.
Water actually is really good from a heat transfer perspective. It's good at carrying heat per unit volume. Salts are just as good at carrying heat per unit volume, but salts don't have to be pressurized. And that, if you remember nothing else of what I say tonight, remember that one fact. A nuclear reactor is a rough place for normal matter. The nice thing about a salt is it's formed from a positive ion and a negative ion, like sodium's positively charged and chlorine's negatively charged, and they go, we're not really going to bond, we're just going to kind of associate one with another, you know? And that's what's called an ionic bond. Yeah, you're kind of friends, you know, you're...
Facebook friends.
Facebook friends. All right, well, it turns out this is a really good thing for a reactor because a reactor is going to take those guys and just smack them all over the place with gammas and neutrons and everything. And the good news is they don't really care who they particularly are next to. As long as there's an equal number of positive ions and negative ions, the big picture is happy.
Improve technology. Don't say no nuclear power, say better nuclear power.
The climate scientists who wrote that letter, or myself, nobody is advocating building 1970s era nuclear reactors. We are excited about the next generation reactors that can be produced in factories, on assembly lines, all technology, an iPhone and wind turbines, solar panels, pocket calculators. The cost comes down dramatically. The reason nuclear power is expensive right now is we haven't been building it.
I think it would unleash a lot of human potential that's currently not being fully fulfilled. Standard of living does correlate quite well with access to energy.
Every time mankind has been able to access a new source of energy, it has led to profound societal implications. Human beings have had slaves for thousands and thousands of years. And when we learned how to make carbon our slave instead of other human beings, we started to learn how to be able to be civilized people. Thorium has 1,000,000 times the energy density of a carbon-hydrogen bond. What could that mean for human civilization? Because we're not going to run out of this stuff. We will never run out. It is simply too common.